Hello students, now we are going to see state tables and graphs from 5th module, that is registers and counters. First I will tell you why we need the state tables and graphs. See, the constructions of state tables and graphs provides a more systematic approach for the analysis of larger circuits. Okay, there are two models to construct these state tables and graphs, Moore model and Mealy model. Okay, we are going to see about both the models only. See, Moore model, here the output depends only on the present state but not on the input. But in Mealy model, the output depends on both current state as well as inputs. Okay, first we will see about Moore circuit. One more sequential circuit is taken. You can see here D flip flop is used, so inputs are DA and DB and output is Z. Now the next state and outputs of this circuit is, we know the next state of D flip flop equal to D. Next state Qn plus 1 is equal to D. Okay, this is the characteristic equation of D flip flop. So that only. So I need DA value. DA is X XOR B bar. DB is equal to A or X. Okay. Next I am writing what is my next state. Next state is A plus and B plus. A plus is nothing but DA, which is equal to X XOR B bar. B plus is nothing but DB, which is equal to X plus A. Then Z. Z is equal to A XOR B. Okay. So by having this equation, we'll write the transition table. So there are two inputs. So 4 input conditions, 0 0 0 1 1 1 and 1 0. Okay. If x is equal to 0, what is my next state? If x is equal to 1, what is my next state? That I am going to find. So for that, in these two equations, I will substitute a is equal to 0, b is equal to 0 and x is equal to 0. So I will get all these. Then a is equal to 0, b is equal to 0 and x is equal to 1 means I will get this. So all the inputs I will substitute and I will find what is my next state when x is equal to 0 and when x is equal to 1. Then z. Then in this equation I will substitute first 0 0, I will get this, 0 1, I will get this next output. Like that for all the 4 combination I will find my z. Okay. Now I have to convert my state transition table into state table. Okay. For that, there are 4 states. For each input condition is being considered as state. So this is state 0, state 1, state 2 and state 3. Okay. We have to convert everything. So it became S1, S2, S3, S0. So 1 0 is here. 1 0 is nothing but S3. So in the place of 1 0, I will write S3. Okay. Next, one more I will check. This 0 1. 0 1. 0 1 is S1. So in the place of 0 1, I will write S1. Here we will check. 1 1. 1 1. 1 1 is S2. So in the place of 1 1, I will write S2. Z remains same. Okay. So first I will write transition table from the expression, next state equation. Then that I will convert into state table. Then state table I will convert to state graph. Okay. So state table I will convert into state graph. 4 states, S1, S0, S2, S3. All the 4 states we have to mention inside the circle. Why we need the circle? See, in Moore state model, each state output is defined within the circle. The format of this is S/Y. S means state of the circuit and Y means the output of the circuit. Okay. So first state S0, the output is 0. So we have to write S0/0. Then S1, output is 1. So we have to write S1/1. S2/0. S3/1. Okay. So everything is over. Now, present state is S0. If x is equal to 0, my next state will be S3. Present state is 0. If x is equal to 0, my next state will be S3. So I have to put the arrow mark here. Okay. This arrow indicates the next state. Next, if x is equal to 1, my next state will be s1. If x is equal to 1, my next state will be s1. Okay, so this s not over, then s2, s1. If the present state is s1 and x equal to 0, my next state will be s naught. Okay, if my x is equal to 0, my next state will be s naught. Then x is equal to 1, s2 is my next state. X is equal to 1 means s2 my next state. This is also right. Then s2, for s2, if x is equal to 0, next state will be s1. Okay, x is equal to 0, next state is s1. Then x is equal to 1 means next state will be s2. X is equal to 1 means next state will be s2. So again it's s2 only. Okay, then s3, for 0 s2 is the next state. For 0, sorry, s3 no, for s3, if x is equal to 0, s2 will be the next state. If x is equal to 1, s1 is the next state. So s1 is the next state. So like that we have to convert state table into state graph. Then Mealy sequential circuit. This is a sequential circuit. You can see in the previous circuit, more circuit, you can see the output. It depends only on A and B. So it is called a more sequential circuit. Mealy, you can see Mealy. This is Z. These are the states. A and B are the states. X, B, X, A all inputs. See the Z, it depends on X, B, X, A, B and all. So it depends on inputs as well as states are A and B. It depends on inputs as well as present state. Hence it is called Mealy sequential circuit. Okay, so this is the circuit. We used JK flip-flop here. Okay, so we know that we know the characteristics equation of JK flip-flop. From that we will write the next state. So next state, A plus is equal to JA A bar plus KA bar into A, because this we have written from the characteristics equation of JK flip-flop. Okay, so J is nothing but X and B, that is written here, into A bar. Then KA bar actually, KA bar is X bar into A. Then B plus, for B plus again JB B bar plus KB bar into B. So JB, you have to check, JB is X. So X B bar plus KB is X and B. X and A. So if you simplify it, you will get this equation. Then Z you have to write, Z is equal to X and B bar, X and A, X bar, A bar, B bar, all together with the OR gate you have to write. So you will get this equation. Okay, then if we will write Mealy transition table. So in this equation you have to substitute A and B, all these values. X is equal to 0, you will get A plus B plus. If X is equal to 1, A plus B plus, this you will get. Then Z also, in this equation you have to substitute all these values. AB and Z is equal to, X is equal to 0 means you will get this. AB, all these values, with X1 you will get this one. Okay, then you have to convert this into state table. So when you convert 4 states, S0, S1, S2, S3, everything. So here also everything you will convert into states. This will remain same. Okay, then this you have to convert into state graph. This is the state graph of Mealy circuit. Next is Mealy graph. Okay, so this is table, state table to state graph. 4 states, all 4 states are mentioned here. In Mealy circuit, the output is written by the side of input along arrow path in the format x/y. X is equal to input, y represents the output. Okay, so inside the circle you have to mention only the state. Then with the slash you have to mention input as well as output. Okay. Current state is S naught. If S is equal to 0, your next state will be S naught only. Okay. Current state S naught. If X is equal to 0, X is the input, and output will be 0. That you are mentioning after the slash. Okay. Next, if X is equal to 1, X is equal to 1, state will be 1. So state moves to S1 and the output is 1. So after the slash you have to write 1. Then S1 state, you are in S1 state. If S is equal to 0, your next state will be S1. So input is 0, output is 1 here. So you have to mention that 1 here. Next, X is equal to 1. X is equal to 1 means next state will be S2. S2. Input is 1 but your output is 0. So that 0 you are mentioning here. Now for the state 2. For X, if X is equal to 0, your state will be S2. So again it moves to S2 only, it remains same. Okay. Input is X, output is also 0. That I have mentioned here. Then for X is equal to 1, next state will be S0. For X is equal to 1, next state is S0. Input is 1, output is also 1. That is mentioned here. Then S3. We are in state 3. For X is equal to 0, state 3, next state is S3 only. So same state. Input is 0, output is also 0. This output is also 0. Next, for X is equal to 1, next state is S1. So you should move to S1. Input is X is also 1, output Z is also 1. This one. Okay. So these are about Moore and Mealy sequential state table and state graph. Thank you.